Okay. So I am the lead of the network and API team, and I'm also giving an update today about a lot of the media side of things. So I'm just letting you know that I'm not, that the things I know about the media side of things are things told to me by the other leads at Chrome. So going down the list of things that we saw on recently, the themes are that we're improving performance and adding codec or improving codecs, and also adding some new capabilities when it comes to how media can be captured. So going down the list, we've added ECDSA, which is a new form of
Yeah. Did you want to show your slides, Peter, or do you want me to show this for you?
Sorry, what was that?
Did you want to show your slides, or did you want me to show them here?
Sorry, I thought they were going to be. Yeah, if you could show the first slide.
I'll let them up. Yeah.
Titled Recent Progress. But if you can't, then I can.
I got them up here. Keep going.
You got them up?
Yep.
So the first on the list is ECDSA, elliptical curve photography, and the next few are related to capturing media. They're technically part of the Get User Media package, which is somewhat separate from WebRTC, but they're related. So we've made Get User Media more standards compliant. It's not prefixed anymore. It uses promises. We've also added new capabilities so that you can capture from a canvas, and that allows you to do lots of interesting demos or game type things. We've added the ability to record media and then play it back. You can record either from local or remote tracks. The codecs supported there are a subset of the ones supported by for WebRTC transmission of audio and video. They include VP8, VP9, and Opus. We've added the ability through behind flags at the moment to screencast audio, or rather capture audio from the system, which then can be cast. And also Apple browser window, which can add a little bit of privacy. We're planning on making the user interface for picking which tab or which window. We're planning on making that a little nicer. There's like a revamp to that coming. On the performance side of things, or the codec side of things, also we've improved bandwidth estimation quite a lot. That's like an ongoing thing. We're always improving bandwidth estimation, but in particular, recently we've improved it for situations like when you have a full mesh. If you're doing, say, a 4-way or 3-way call, and you're sending your audio and video to multiple other peers, not just one. And also in competition with TCP streams. So if somebody's downloading something big at the same time as using a call, the bandwidth estimator should operate better with that TCP stream. So on the codec side of things, we now have H.264 desktop and VP9. In particular, VP9, behind a flag, we have experimentally added SBC support, which is of interest to anyone that would be doing multi-way with fan up through a server. So if you go to the next slide, the roadmap is basically kind of the same things. We focused a lot on making our performance better, the bandwidth estimation, the echo cancellation, the video rendering, using less CPU, using hardware more, etc. We are always trying to make it more standards compliant, like we have done with Get User Media recently. And we also have some experiments that we put into the WebRTC implementation, webrtc.org. We usually have it there before it will show up in Chrome because it's easier to experiment there before we put something in Chrome. So for example, we've added a mechanism in ICE called continual gathering, which allows you to have a more robust connection, especially as network conditions change without needing to do ICE restarts. We've added the RTP center objects from the spec, either the, you got it, but haven't yet exposed that to Chrome. And we've also experimented with Quick in different channels. So if you really know what you're doing, you can go and try and compile it with support for Quick data channels. But we continue those experiments and see what works well and what doesn't before we try and either stand by additional things or put things into Chrome. So if you wanted to see where the latest experiments are, you would go look in the repository for standalone WebRTC. So that's about it for me.
Thanks, Peter. If you could just hold tight, and we'll come back to the audience and some of the questions I sent earlier in about 20 minutes.
Okay.
So with that, I'll.
Okay, sure. So yeah, as said, I'm Niels Omeyer. I'm one of the engineers on the WebRTC team at Mozilla. Just a little bit of history. Firefox has WebRTC support since release 18, so quite some time already. Initially, that was done by just a very few folks. Most of them actually are on different teams, just helping out. But now these days, we actually have a team of more than 10 people dedicated to WebRTC, working on all the different bits of pieces like transport, media, JavaScript API, and so on. So team has grown, still growing, so strong support there. Just some basic interop. We support VP8, H.264. We recently added VP9 support. On the audio side, we have Opus, G711, and G722. On the transport layers, UDP and TCP, hopefully going to come this quarter. The introduction on Firefox for the what we call electrolysis, which basically separates the content process from the actual browser process, basically slowed that TCP, ICE-TCP a little bit down. We do have turn UDP and TCP support, still no TLS support. We're looking into that. Then just to give you an idea, this matrix is not from us, but from Philip Henke, or Hanke, I should say. So as you can see, Firefox, we try to really support as much of the different features which are there in WebRTC. And then I wanted to address one question we get quite often is okay, so Firefox, you use the webrtc.org code, which comes from Google, so then your WebRTC implementation is the same as the one in Google Chrome. And the idea behind this slide is to basically say, no, it's not the same. As you can see, in the green box, that's basically, yes, we import the code from webrtc.org, and that's a central and vital part of our architecture here. But all the pieces in white is basically the code we have written from scratch in Firefox, and all the orange pieces are basically third-party libraries, which are depending on which piece we're talking about. For example, libopus, we actually have people working on that a little bit, like some of the media guys. But then for example, libsctp, that's completely third party. I mean, we know the people who are working on that, but there's no Mozilla staff is working on that. On the other hand, the ICE stack, for example, is a third party library, but we modify it heavily to keep up with all the new things coming down the pipe for ICE. So yeah, that's just to give you an idea. There is some similarity, but it's quite different. And one of the main reasons we actually this was actually in the beginning of the WebRTC project at Firefox. This was a big question, which route should we go down? Should we basically just take as much as we can from Google? And we made the explicit decision to no, we don't want to do that. We actually want to have a separate implementation from the Google one, because we actually believe this is an open standard and we want to foster interoperability. And if we would have just taken all of the code from Google, then probably would have worked all the time, but we probably also wouldn't have found any bugs in the specification or in Google's implementation. last slide is just a little bit of roadmap. So next quarter we want to focus on conferencing. So that's so far we basically paid most attention to the one-to-one calling scenario. Now we get more and more requests to improve the audio quality and conferencing experience. We have simulcast support. But if anyone out there basically works on simulcast, please get in touch with us because we want to actually test it because we don't actually have any endpoint we can test it with basically, and so that spec is still pretty early, but it would be great to get interoperability going. And then we want to add more better support for enterprise customers, which is, for example, support like HTTP authentication for proxies, and obviously also update to the latest draft changes. That's it.
All right. Thanks, Nils. And Bernard?
Okay. So a little bit of an update on the Edge Realtime platform. It's about a year since we originally shipped support for real-time communications in Edge. At that time, we shipped with support for media capture and streams, get user media, as well as ORTC. And mostly that release was focused on interoperable audio. Since then, in the Windows 10 anniversary update, we have shipped support for H.264 AVC Experimental. That is now in the latest Windows Insider Preview builds on by default. We also have, behind a flag in the latest Windows Insider Preview support, native support for the WebRTC 1.0 API. So if you go to About Flags, you can turn that on in Experimental and play with that. VP8 has gone into development. That is not yet available in preview, so you can't play with it yet. And then there are the things which will be on the backlog, and when we get finished with the work that we're doing, we'll consider those, and that includes screen capture and media recorder. So a few other little things. As part of the video work for both H.264 and VP8, we are going to be working on robustness. So if you look at the latest Windows Insider Preview, we have support for retransmission RTX, as well as the feedback message generic NAC. In Windows 10 Anniversary Update, we ship support for PLI. The RTX and generic NAC support is still a little bit weak, so that's definitely a developing thing. We have had support since Windows 10 Anniversary for integration with both Canvas and Web Audio. So you can take remote audio as well as local audio into Web Audio, and then remote as well as local video into Canvas. So we do have that integration. I should also talk about the status of DTLS. We originally shipped with DTLS 1.0 and then upgraded to DTLS 1.2 in Windows 10 Anniversary Update. We are still generating RSA certificates by default because we don't yet have support for the Certificate Management API, but we can validate ECDSA certificates, so I don't believe we have any issues with other browsers that put out ECDSA by default, so I think that works. So a little bit about the Edge ORTC object model. If you've looked at the regular ORTC objects, there are a couple of things that are different. We support basically the objects that are in the WebRTC 1.0 object model, roughly, which includes the sender, the receiver, the DTLS transport, the ICE transport. We do have the ICE gather as well, which is unique to ORTC. We also support, in addition to DTLS transport, SRTP SDES. That's something that probably doesn't have a long-term future in Edge, but it's there now for people who need the legacy. And there are a couple of objects from ORTC that we do not implement, including the RTP listener. So we drop packets that can't be routed. That's more or less what happens in WebRTC 1.0. And we don't support the ICE transport controller because the way we do freezing is kind of the order of the ICE transports. And so it basically, the way you think about it in adapter.js, the SDP that gets outputted there is what will control the freezing order. Okay, so a little bit what's in Edge or ORTC in some more detail. For the audio codecs, we have G711, G722, Opus. We have Silk, Comfort Noise, DTMF, Red, and a proprietary external FEC at the moment, which does burst loss resistance. We would love to get a little bit more testing on the Red. I'm not sure how well that interoperates, so not a lot of testing there, but the other stuff does seem to work with other browsers. For video codecs, in the current Windows Insider preview, we have H.264 AVC, which is actually on by default. It's experimental and anniversary update. We also have an implementation of H.264 SVC, which we've had since the first release, as well as something called ULP FEC-UC, which is both of which are only accessible via ORTC and won't be in WebRTC 1.0. And that's basically an implementation of H.264 SVC with forward error correction and burst loss resilience. I mentioned the feedback messages and RTX and VP8. For stats, we have something very similar to the stats model in the stats spec, but in ORTC, the stats hang off the objects, so you have to retrieve them in a little bit different way. We also have some very detailed supplemental call statistics, which include a lot of additional stuff related to burst loss and forward error correction effectiveness. And then the usual kind of multiplexing features, bundle, RTP, RTCP mux. The only thing I would say is that with DTLS transfer, we do not support non-mux. So you basically have to multiplex RTP and RTCP. With the SDES transfer, we do support non-mux. We support IPv4 and IPv6, and I mentioned the DTLS 1.2 stuff. So a few limitations: don't have the data channel or screen sharing. That is, they're both under consideration. We do not support forking, which is something that is in ORTC, but in our implementation, you can only have a single ICE transport per every ICE gatherer. To detect state transitions, we don't support the ICE gatherer state attribute or state change events, so you have to look for the null event.candidate to find the end of candidates. We don't support unhandled RTP or SSC conflict, and I mentioned the certificate management issues. So a little bit more about the WebRTC 1.0 support on ORTC. Since we first shipped, the adapter.js library shortly thereafter came to support Edge. So if you use that library, you get an emulated WebRTC 1.0 API, which conforms to the latest spec. So for example, whether or not the underlying browser has promises for get user media or the other RTC peer connection methods, you'll get the promise support that's there. And so you can actually write 1.0 apps that run on top of Edge, ORTC. And there's some links for that. And actually now with the H.264 ABC, you can write interoperable apps, and so you can do a demo of audio and video peer-to-peer that runs on all browsers. Now, a lot of questions I get relate to how whether people should use the native 1.0 support that's now in preview or this adapter.js. And let me try to describe the differences and goals between those two approaches. So adapter.js tries to keep up with the latest version of the WebRTC spec. So for example, the WebRTC spec now has objects in it. So as that comes into all the different browsers, adapter.js will support transceivers and senders and receivers and all that stuff. And since the underlying object model is there in ORTC, it's our expectation that adapter should be able to be fairly faithful to the 1.0 spec, and we should get fairly good coverage there. But in our 1.0 native implementation, really the goal is a little bit different. It's mostly to support just the what I could call the legacy WebRTC spec, so without objects. And for some of the more advanced functionality like the simulcast, will primarily, to surface that in 1.0, will primarily be through adapter.js. So we're not trying to, And in the testing we've done so far, the native support is slightly more faithful, so it passes more W3C tests than the adapter approach. But I think in the long term, adapter will probably have much greater coverage and be more up to date with respect to the WebRTC 1.0 approach. So my advice to developers is if your application can run with adapter.js, that's what I recommend, because in many cases you want to use that kind of approach anyway to get your stuff running on all the different browsers. So that's my personal feeling, although it, in some instances there might be some lack of faithfulness in that. So I just talked about that. Yeah, I think I've pretty much done this. Basically, if you want to try this on by default, get the latest preview. A couple of things, just some details. We support in the H.264 ABC the baseline profile up to level 4.2, so it's encoder does a little bit higher resolution than some of the other browsers. We support packetization mode 1 only. Also, we support the absolute time header extension. You'll notice in the latest Insider Preview we do support Google Rembi as well as a generic NAC. And I mentioned the support for RTX is a little bit shaky. And if you do use adapter, I would recommend some of the latest patches in 2.04 because they basically filter out the RTX since it's kind of shaky and will probably interop with some of the other browsers. People also ask me about VP9 because the site says it's supported, but I want to clarify what that means. We are going to support VP8 encoder and decoder in both ORTC and WebRTC 1.0, H.264 also in WebRTC 1.0. But VP9 currently is for streaming scenarios, so there's only a decoder there, and so you will not see VP9 advertised in either WebRTC 1.0 or ORTC until we get the encoder and the thing is actually generally useful. And here's some places you can get more information. We work with Chad to do an Edge FAQ in WebRTC Hacks, and there's an updated version of that here, which talks about where we are with respect to the latest preview. There's some developer docs that tell you all about the ORTC API and exactly what's there and any variances with the ORTC API spec, a blog about H.264 ABC, and then Skype for Web, which actually runs now on Edge ORTC. We have a beta for Chrome, which is doing audio and video, and we are working on a version for Mozilla, Firefox, so stay tuned for that. Thank you.
All right. Thanks, Bernard.
Switch Peter back.
Hey, Peter, you still with us?
Yeah.
All right, great. So I probably have enough questions to keep these guys here for the rest of the day, but I'm going to start out with just a couple questions, and then I'll transition to let the audience do a few. Maybe to start at just a higher level, I'd be curious to hear what are your development priorities, right? There are 3 different organizations, 3 different browsers. You have to interoperate at a certain level, but you certainly have different focus areas. So I'd be curious to hear your comments, I guess, of what do you really care about, what's driving your development? Maybe Peter, just to make sure you're still there, can you start on that one, please? Hopefully you heard it.
Sure. So the question was, what are development priorities?
Yep.
So our 2 big priorities are improving quality and the tools that the developers need. So if there's something missing in the API, and if there's something that doesn't work the way the developers expect it to, we want to fix that. So mainly making the experience better for the developers and performance once the API works like it's supposed to. Just the ongoing call quality.
Are there certain applications within the Google portfolio or just WebRTC applications in general that I guess get preference versus other ones?
We take feedback from developers pretty seriously. So when people come to us and ask for things, that's what we take as input. And recently, you may have heard of the Duo app. That was an opportunity for us on the network and API team, my team specifically, to address issues that our SAC had in mobile environments that maybe other developers haven't run into yet. And so we really honed in on that, making the WebRTC code work a lot better in mobile environments. So in some sense, we were giving priority to the need of that app at that time, but it was really a great opportunity for us to address issues that I'm sure other people are going to run into. That we wanted this thing called continual price, and that was all because there was a mobile app that needed it, that hadn't needed it previously. So in effect, a Google app acted as a guinea pig to force us to improve things where I think other developers are going to need it. A similar thing happened earlier when we tried to port Hangouts, and this was years ago. When we ported Hangouts to Chrome, there were many things that we found that didn't work well for that context. We had lots of things that didn't be needed. So we take feedback for what's missing from developers, both third-party and first-party.
Thanks, Peter. Maybe Niels, I'll let you go next.
Sure. Yeah, I think, I briefly mentioned already, like, the next upcoming things we want to work on. So maybe I can talk a little bit more about, like, what drives our roadmap. And I think that's, like, what maybe differentiates us as an open source company a little bit from Microsoft and Google in this case is, like, you guys drive our backlog. Everything in Mozilla is a bug. So just an example, I just recently filed like 2 bugs for like the missing DTLS transport object and the ICE transport object. And I just made like gut feeling judgment there and said like, okay, the DTLS transport object, I think that's actually a pretty good feature from the ORTC spec because right now in WebRTC.1 you don't have like any way to figure out whether DTLS failed. And so I gave that like a higher priority because I think that's like something which developers probably want to know about. If ICE worked but DTLS fails, then you're basically dead in the water and you want to know about it. I also opened a bug report about the ICE transport missing, and there I made the judgment and said like, well, most of the information I think you can get today already, so this is lower priority. But if any one of you thinks differently, comment in the bug report. Come into our IRC chat room, go on our mailing list, Dev Media, and tell us about what you need. And this is really, I mean, like, I'm not really driving the whole backlog. That's basically my manager, Mary, but she basically, her decision on what we are going to focus on, like, as I said, for next quarter, like conferencing, for example, is really driven by the feedback we get from the developers and the community. So when you guys like scream loud that you need this feature or another feature, then that will drive up the priorities on what we're going to work on next. Yeah. So
thanks. Bernard, can you comment on, I guess, how does Microsoft prioritize?
Sure. So in Edge, we have a platform status site, and actually you can vote on features. So we actually take input through the voting. And so several of the features have gotten pushed up a little bit because they got a lot of votes. WebRTC 1.0 got a lot of votes. Screen sharing got a lot of votes. Media recorders getting a lot of votes. So those are also, it turns out, the red items that were on the chart that Neil showed. So a lot of those things are high. Getting video to work, I would say, is probably the biggest goal for like the next quarter, maybe the quarter after that. So that's, finishing VP8, the resilience features, the RTX, moving on to the forward error correction. So all that kind of things to fill out, and the feedback messages, filling out the video support, and then doing the red items. So that's what I'd say. Looking out for, say, the next 6 months to a year, that's probably what I'm going to be working on.
Yeah, I mean, are those driven by specific product needs, like, Skype or Web or other teams?
Well,
I guess?
so we also...
I guess you're guinea pig application.
Yeah, so I'm kind of in the interesting... I work on the Edge team, so I work on implementing, but I also work on the Skype team helping to be on all browsers. So we kind of have 2 products that we ship across all browsers. Skype, which is the consumer service, which is more the peer-to-peer kind of stuff. And that's the feature set that's most, I would say, Edge is most oriented to at the moment, and that we can get running on all the other browsers. So that basically requires, resilient audio and video, and the screen sharing is also very helpful. And then we also have Skype for Business, which is more of a conferencing product. That requires a boatload of features, so much longer feature list. So that's actually tougher for us to satisfy for Edge. It's tougher to get all those features on all the browsers. So that one is kind of a more We certainly have a lot of pressure to do it because it generates more income than Skype does. But that's a kind of a longer laundry list and basically requires every feature in the WebRTC 1.0 spec and every feature in ORTC. So I hope that but they share a lot of code. So, the Skype stuff will probably get done first, and then as we fill it all out, goes to SFB.
My next question is, you're all need to interoperate with each other, make websites work, but you're also competitors, right? They are competing products. You're competing for market share or mind share. So when it comes to WebRTC and RTC support, what do you see as your differentiators? Is there a drive to be a specialist in one area? I have a lot of opinions I could probably answer for you, but I'd like to hear your thoughts. Maybe we'll start with Bernard.
Okay. So one thing is because we're not only building a browser, but we're also trying to operate a very, very large service across multiple browsers. One of the two things that come out of that become very, very high priority. One is testing, automated testing, and the ability to test not only our own stuff, but interoperability with other browsers before they become service impacting events and we start getting millions of phone calls. So that's really important. The second is operational stats. And if you've taken a look at our specification for Edge, you'll notice that we have probably 5 times the size of statistics than that is in the WebRTC spec. So it's actually most of the spec is devoted to stats, and that's how we do our operational operating of the service. So that's one thing that I think we're very, very focused on, and I'll probably end up, as soon as we get some of the basic stuff done, spending a huge amount of time on operations and stats. I don't know if you'd call it a differentiator or not, but it's something that's absolutely critical if you're trying to support millions and millions of people on a browser.
Niels?
For us, I think one of the big drivers, or what we always try to pay attention to, is basically stay up to date with the spec and be spec compliant and basically be true to the open specs and standards. Like for example, we get from time to time, just the other week I had a bug report where it turned out that we do actually rate controlling according to the spec on the ICE layer. But the bug report was basically, hey, Google Chrome actually is able to penetrate my net firewall. Firefox is not. With some tweaking, it turned out Google actually retransmits very aggressively and doesn't do rate controlling, and therefore it gets through there. When I modified Firefox to do the same, I was also able to penetrate the firewall. Unfortunately, now I'm violating the spec. So these are the hard decisions we have to make. But yeah. I think that's we have all of our APIs are promise based, I think that's the big our advantage basically currently.
Okay, maybe I'll ask you, Peter, the same question. How do you see Google differentiating with real-time communications in the stack? What are your focus areas?
So it's kind of an interesting question because we don't really try and differentiate per se. When we sit down and think, what are we going to do next? What are our priorities? We're not thinking, how are we going to be better than the other browsers? But I guess there are 2 things that do make us different. One is that the code that we write is not just for the browser. It's also available as a library for mobile apps, and it's used by a lot of mobile apps. So if you want to make a mobile app to go along with your web app, then the code that we have at webrtc.org is available for that. It's roughly the same API that's available on the web. Sometimes it's a bit ahead. And the second is that we're in really close contact with applications that are using it in very large deployments. And so we get feedback about work well or don't work well, and we can improve on those in ways that benefit everybody, but they're sort of quiet under the hood where performance gets improved. So I think in many cases our stack performs really well because we're in that close contact with applications, wide deployments there. detailed feedback about their pain points.
Thanks, Peter. So my next topic area and discussion is around specs. And Niels, you talked a lot about this. We've typically had some sort of standard specification update here, and it's always next time it's going to be a standard ratification, everything ratified. I know we're pretty much we're basically done for get user media, but the peer connection is still ongoing. So I do want to ask the question: how important are the specs, and is, if it's always a moving battle, is it ever going to be done? And how important is it that actually you adhere to specifications versus, I guess, doing what works for developers out there? Niels, if you go first, please.
Sure. Well, I mean, let me start with saying, like, I wish the spec would be done, and it wouldn't be a moving target, because that's actually causing us a lot of pain, obviously, as well. Yeah, the adhering to the spec, I think for us is really important, because I think we see it as this is something all the people, all the developers, all the community out there rely on. And like basically, if we decide to not adhere to the spec, then that's basically an unexpected behavior. And then if someone basically writes like a service on top of our platform, and we see it as a WebRTC platform, they expect a certain behavior from it, and if we don't behave like that, then they have to put extra code there to deal with that. And so that's why I think like Mozilla has like also lots of people contributing to the IETF and the W3C to basically make sure that the spec goes in the direction we think is right, and then on the other hand have like the developers implement it that way that we think it's right. And again, like if you think things are not working as you wish, then like let us know through the bug reports. I mean, that's if you convince us, then we will also go to the standardization bodies and basically be your advocate and try to make it right.
Yeah, so Peter, maybe I'll ask you next. I mean, I think you and Bernard probably have an interesting perspective on this, since you've both worked on the 1.0 spec and also a part of the ORTC community group and pulling that in. What are your thoughts on the specifications? Do they, if it's going to take forever to standardize, it's never going to happen, do they matter? How does Google think about that?
Well, I think the important thing that the developers can do what they need to do, that indicate to them, and that those work the same across the different browsers, so they don't have to change a lot for doing browser-specific things, and that the browsers all interoperate, so that you can have an app running on two different browsers and they communicate. And I think the spec is a means to that end. And so when we work on spec compliance issues to make sure that our browser is in compliance with the spec, and when we work on the standardization process, that's really the goal. Web developers can write these applications, and it works in different browsers and across browsers. So I think the specs are very important, because if we don't write down what the API, what the browser is supposed to do when the API is used the way the developers use them, then we can't have an agreement. But it is good to recognize there are areas of the spec which are more important to developers, and areas that are more kind of edge casey, like you sit down and you say, this theoretically could happen, but we don't know if anyone will ever do that. So there are parts of this important than others.
Yeah. Would you say, are there a lot of areas that you would say Google is willing to move ahead of the specification for and catch up later? Do you have a general approach for, how do you choose when you go ahead of the spec versus when you wait for it?
Sorry, I had a little hard time understanding the question. Can you say it again?
Do you have does Google have a general approach for when you choose to go ahead of specifications versus waiting for the specifications before you choose to implement something?
So our approach, for example, with our improvements to making ICE work in a mobile context, our approach is to think of ways that we can solve real-world problems with extensions to the existing specs that we can go to the standards body and propose. So, for example, in the ICE working group, we recently proposed 3 different extensions for improvements to ICE that work well in a mobile context after having tried them. So we'd like if those got standardized so that the browsers can implement them and all the browsers can work better in a mobile, when they're, not just when they're run on a mobile platform, but also when they're communicating with a mobile app. And so that's the approach we take, is to start with real-world problems, try and develop solutions, but with the idea that we will solve them with pieces that can build on top of the existing specs. Okay. And then propose those in the standards.
Thanks. And Bernard, I mean, on Edge, I mean, you chose to start with ORTC, the future spec, not the current one. Now you've gone back to it. Can you talk a little bit about your thinking and approach there?
I guess the first thing I'd like to say is to kind of describe where I think where we are with WebRTC 1.0, which is that we've added this object model. It was a pretty significant addition. But we don't really have enough implementation yet for 1.0 to really finish it. So I think that's a case where the spec is probably ahead of the implementations. And I'm expecting as the implementations come in, there will be a lot of bugs filed as people look at it and understand it better. We do have questions that come up, even just like yesterday in my email, somebody asked a question about why does it say this, and we that's wrong. So that happens from time to time. With respect to ORTC, as I mentioned, we've implemented most of it. There's some things we're not sure are quite right, and so we've kind of abstained from implementing those portions, and we'll see going forward whether those stay in or something else happens. But I would say in general there's an interaction between implementations and the spec, and you really don't know if the spec is solid till people go implementing stuff. I know I've been put in charge of all the DTMF bugs because Firefox has been implementing that and asking lots of questions. So that's kind of what happens. You see as people implement things, the bug count goes up and hopefully eventually goes back down.
All right, so maybe, Bernard, I'll ask you a follow-up question. I mean, and this is about adapter.js, right? Which is kind of turned into somewhat of an interoperability layer to fix up all the issues with WebRTC between implementations. Do you see that as a temporary thing until basically everyone gets on the same page, or is that going to be around for a while? And maybe you can also add.
Just in my opinion, I think it may be temporary for Get User Media, but I don't think it's going to be temporary for RTC per connection. There's just so many little tiny differences between browser implementations that it really has turned out to be very useful. Even in the object portion of the spec, we're seeing differences in the way people are doing things. So that's just my opinion. I don't want to say it would never go away, but it could be here easily 5 years from now. And just also writing code, like I wrote some demos for the tutorial. It was way easier to write them with adapter.js. Didn't have to do any SDP munging. It was just like a dream come true. I could just read the spec and just write code, and it just worked. So that was very, very nice. But it won't work for everyone. I mean, don't try to write a conferencing app with adapter.js. That just won't work.
Niels, what do you think about adapter.js? And can you maybe comment a little bit too on just for those that don't know how does Mozilla and your team work with that?
Yeah, I mean, I certainly hope that actually a little bit controversial to what Bernard just said, that I would hope that adapter.js one day goes away, but I don't see it in the near-term future, because what would have to happen is basically that we would have to have a 1.0 spec, and then all browsers would have to implement every last bit of the spec, and then eventually, hopefully, adapter.js could become like really, really small and maybe go away. But I'm assuming by the time we are all going to working on like WebRTC 1.5, 2.0, God knows what, and you will probably be there will probably be an adapter 1.5, 2.0, whatever, and so probably people will keep using it. I could only see that if someone basically wants to write like a WebRTC 1.0 compliant app in like, I don't know, 2, 3, 5 years, I don't know exactly. And if he's sure that he never wants to update, then he might be good. It might be good enough to just rely on the browsers and don't use the adapter.js. But otherwise, I think it's a very useful tool. And Mozilla, actually, we have like multiple people working on adapter.js. So basically, as soon as we change our implementation, the same developers basically go and change the adapter.js portion for Mozilla Firefox to keep that in sync. And make sure, and we also make sure that it not only supports like the new implementation, but also stays backward compatible. I can only agree on like every developer basically should use adapter.js. Otherwise, you just spend time writing your own shim code to support all three browsers, and that's just a waste of time.
And it's messier shim code.
Peter, maybe quickly you can comment. How do you think about adapter.js? I mean, you probably agree that most people should use it. Do you think it should be? Do you think it'll be around for a long time too?
So I hope that as the browsers converge more, that the number of cases where people need adapter.js will shrink. It might be the case that slightly more advanced things would still need them, but hopefully even that will go away over time, at least for people that need 1.0 API. Now, obviously, if there's new versions of the API after 1.0, then there will be a whole new need for a new version of adapter. Just in the context of 1.0 API, I hope that as time goes on, it won't be needed anymore. But certainly for the time being, it's the right place to start for web applications.
So I'm probably only halfway through my short list of questions, not the long list, but I did want to open it up and give the audience a chance. So why don't we take some audience questions? Let's grab the microphone.
Oh, great, thank you. So I'm curious if we've seen any signs of life out of Cupertino besides a job listing.
Yes, it's on their webpage. They're working on it. I mean, that's the only additional information I know.
That's just work in progress. That's all we've heard so far.
Yeah, I think I forgot the exact URL, but it's similar to like the Microsoft page where they say like what features Apple is working on for Safari, and sometime after the job posting, WebRTC made it on that web page, and I think it's marked as in development right now.
Yeah, I mean the WebKit. I mean, I can probably comment. You guys might know more than me, if you look inside the WebKit code, I think some of the Get User Media and some of the pieces are there. They just haven't enabled it because they don't have the UI mechanism to turn anything on. So they're definitely working on it, but it's definitely not ready yet. I don't know, Peter, if you have any other insight that you could share on what Apple's doing, but guessing not.
I don't know.
Next time we need an
there
Apple representative.
There was one Apple person at TPAC this year.
Yeah.
It was mostly as an observer role.
Yeah.
Not getting a lot of participation.
Other questions before I take up all the time? Dean, I'll let you go first.
Yeah, I got a question. Thanks. What are your, in thinking about the way you're implementing WebRTC, what are your thoughts on or collaboration with the various platform as a service guys? Or do you let them do their own thing and you just do yours?
I'll comment on. So I do the developer relations, and so those are people we talk to, and have them in, and we work with them to get all their platforms up on Edge. So definitely they're great for testing because they do a very wide range of stuff, and so it helps. We've had you notice on our Edge test drive page we had an app from Twilio. So they support Edge, and we're working with other ones to get them, once we have the video features, to get that supported in in those platforms.
Yeah, similarly, I think we try to actually get in contact as many of these providers as we can, encourage them to, on one hand, test as early as possible. On the other hand, please open bug reports on our side, because if you discover something in your servers, we don't necessarily know about it. We have our own data collection, but it's just that collects everything from Firefox, every single WebRTC session, and often bug reports, which Philip Hanke, for example, is very famous for finding. They don't show up in our stats, right? Because he finds like this one little tiny corner case, and we don't see it in this big amount of data we get from gathering. But yeah, we actually have like dedicated people which we try to send out to talk to Facebook if they basically can let us know if they see something unusual in their data, or like Twilio, same thing there. So they're definitely an important and vital part of keeping our platform sane, bug-free, and running.
Peter, did you have anything else to add on that? No,
I didn't hear the question.
All right, why don't we keep moving, just in the interest of time, and we'll let you be the first to respond on the next question. I think, Svein, did you still have your? Yeah.
And this one was for you, Peter, actually. I noted that you said something about better support for mesh networks, and I think it was in regards to bandwidth estimation. Can you elaborate a little bit on that? And for the others of you, is this something you're looking at as well?
So was that a question for me?
Yeah.
Yeah. Can you elaborate on the bandwidth estimation for mesh networks?
So I don't know the details of what they improved. My general sense is that it went from very bad to not as bad, as far as how well mesh networks work in general. If you're doing video with more than a few participants, unless you have a lot of bandwidth, it's not going to work great. But at least it's slightly better now. But that might be underselling it. They might have improved it a lot more than I'm giving it credit for. I would have to go ask the experts on it for more details.
The other panelists want to comment on?
Sure. So yeah, I mean, yes, what I had on my slide, the improved conferencing support, is basically goes to mesh calling, because that's one form of the conference. One of the things we have there on our roadmap, it's not very concrete yet in terms of like when we're going to deliver it, is what we call like shared encoding, so that if you have like multiple peer connections but you send out the same picture over all of them, then you basically do the work, or the idea is to do the work only once, rather than like currently it's basically every peer connection is completely separately, and so each of them like encodes it again and like encrypts it again and so on. So there's definitely room for improvement in that area. So there's stuff which can be done, and it's on our radar. We're working on it. Will take some time.
Yeah, so we do support the group video calling, of course, within Skype, so that is important for the smaller conferences. The bigger conferences are more in the Skype for Business kind of arena, and that's a whole nother set of functionality and issues. That's where the simulcast, the scalable video coding will come in. And those are things that actually we do support currently in Edge, but we're looking to support it on other browsers as well.
Okay. Was there any other one, maybe time for one more quick Niels?
Maybe I wanted to like just for the audience to the title of the actual panel discussion here, just to mention that like I think what we have here between Google, Microsoft, and Mozilla is actually a very positive collaboration. Last week, we got an email from Microsoft asking us about like some interoperability problem they saw in their automated tests. And on Friday, we found out, it's a bug in Mozilla Firefox's SHA-384 implementation, and so it fixes up. It's a Firefox nightly. It's going to come to Aurora and beta. And same way also with Google. I mean, one of the examples is like the data channels, like the way it gets negotiated in the SDP is like the spec has moved forward, and Google's and Mozilla's implementation is like behind. But what we do in these kind of cases is that both sides basically implement the support for reading the new spec, and then once Google and Mozilla have both support for that in the release, publicly in the release, then only one of us will basically turn on also sending it in the new format. So there's definitely a lot of cooperation to avoid that that your services will go down because one of us basically jumps the gun and breaks interoperability, right? So from that perspective, I think I think it's like a really good competitive but still collaborative approach with the user in mind.
Right. Thanks. Unfortunately, we're out of time. I think that was a good close off. I mean, there's a tremendous amount of collaboration that goes on, behind the scenes that probably most people don't see. I think everyone would appreciate having more public collaboration like this and getting you guys on the stage together. This is really exciting for me, so, and hopefully for everyone else. Thank you.